And I think there's one more final presentation given by Clubsim or Jobsim team, as you like. It will be a double conference by Matthias and Christopher, I think.
Yeah.
It's not fair where I do it.
Since it's the last one, and we're actually already a little bit over time.
So we're exactly at the end.
Yeah. Already a little bit over time, so we try to make it, first of all, not too complicated anymore. Second of all, I mean, you saw already a lot of our work as well. But one thing we wanted to do in the end is kind of give a bit of an outlook and an introduction of what we're planning for the future and what are kind of also for those of you who don't know us, a first introduction. In the meantime, we already grew a little bit. So Joachim, the big mastermind behind this whole thing, has founded with us like 5 years ago this spin-off of TU Wien to bring this stuff into industry. In the meantime, we're supported by 3 more people, so Raphael, Sebastian, and Christoph. And our whole goal was, in principle, to first of all support the idea flow of research into NGSolve and bring that stuff into industry. Maybe if everyone in industry is simulating, it would be a bit too much. They should produce as well, but you get the idea. So support the research and empower the experts in industry that want to use NGSolve, because this was kind of like one of the stories back then also, that we had already university collaborations with industry, and they very often broke down because I even was like once approached, do you want to make a company, then we can start this, but like if you're still at university it won't work out. And I was going to Joachim, I was like, should we just do it? So, and now I want to introduce a bit of this like powers of NGSolve, why I think, or we think it's very useful in industry, which is mainly here. And then a bit of the challenges, why is so little or too few industry people are using it. So of course the power is like you have this modular Python framework, you can have building blocks for everything, you can do anything you want. You have seamless integrations to other Python tools like NumPy, SciPy, post-processing, Matplotlib, or WebGUI. And you can even touch anything else you want, like it's open source, so you can hack it and implement your own integrator that does some, I don't know, fancy mesh lumping technique or whatever. But basically, the strong points are also kind of the challenges for us, at least, to sell that stuff. Because industry is quite often a bit reluctant if you need like these high-level super experts in your company to actually use it. And also, in the company, it's hard to distribute it then, because even if we have like this one person who is super enthusiastic about this stuff and wants to bring it, then distributing it to colleagues who are not so enthusiastic about Python and rather want some click-through console stuff is a challenge. And then they also have to fight the managers who say, we won't pay for something that if you leave will be worthless to us. So we, for some time, I think 3 years, tried to tackle this. And we had a lot of discussion with Joachim, and he was always like, no, we don't make it simpler for people to use. This is expert software. And we agree, it should be for expert. You should have all these things. So we need a different approach to be able to bring it into industry. And so we started like in parallel with all this WebGUI, Jupyter-Lite, PyODat development. We were like, actually this is a really nice opportunity to build something where if you build a good simulation software in Python, wrap it, make some small Python components, put it in the browser, make it accessible to everyone in your company or to your research client, for example. So have a platform where you can deploy that afterwards, the simulation, as a click-through, easy-to-use example for your customer. So we started experimenting with this idea and had like, I think, 4 or 5 complete rewrites of the idea. And at the end, we ended up by actually a very simple, thin Python wrapper for Quasar components. Everything runs in Pyodide connected to this JavaScript. So it's super easy to set up an app in it. It's actually, you need to only develop in Python as an app developer. You have all the flexibility of NetGen, NGSolve, WebGui. You can pre-post-process in the browser. And you have also a simple API to handle cloud computing resources. So you can ask, okay, I set up my model here. I create the geometry, but the solving, then we call Patsy in the cloud. Why do we do that? First of all, as I said, leverage this full flexibility and don't cut down on flexibility. Make it easy to write and maintain this app code, which is actually not what you experts want to do, because this should actually not be your stuff. And be able to also, this is kind of an outlook in the future, like things are moving into the cloud. There will be like GPU usage that you will not have in your laptop. So be also able to utilize this optimized hardware that is going to be developed already and is going to be developed. And then tell your manager in the company, be able to, or in your research lab, with this we can actually make all the people use the useful stuff that I develop. So this is basically how it looks like if you log into this platform right now. So you have kind of all the apps available that you have. You can click on them. And I will just now showcase some of the apps that we already built. So we started this with iTribomat, so this tribology project with ACT research, where we first developed some simple calculator apps. So like this is a thrust bearing app. I'm honestly not sure what it calculates. Maybe Christoph can explain that. We just implemented the code for it and did the visualization. It's like, I don't know, it calculates the pressure, hydrodynamic pressure in such a thrust bearing. Or, for example, the Schönel bearing that Christoph already introduced in more detail, where we really do then cloud simulations. We also build our own apps. They were kind of more like a playground to experiment first what kind of flexibility we can utilize. And also we were thinking, okay, if we do that, we can also provide some easy-to-use tools. This is, for example, a meshing app where you can upload a step file, click on the faces, assign names, and so on. Matthias will showcase this shortly. And thankfully, for allowing me to show this also, Martin, we started a pilot also within Siemens Energy, where we're doing this in the company cloud, where they then can simulate the power transformers in this web platform. So how does this work if you are like an app developer? So consider yourself here or here, depending on like if you're in a company or if you're a researcher. You either work with us or you build your own simulation stuff. You contact us, or you will get actually access keys tomorrow if you are interested in. You then start developing the software. If you have questions, you come to like a platform specialist of us that can answer your questions. We have like, for example, Rafael is very known already. There he's hiding. He's already very well known into this like whole platform thing, and he can guide you with your needs. And then you deploy it either on our website, or if you're in a company, they usually are not so happy if you develop simulations and deploy it on a public website where the competition can also access it. Then we deploy it, of course, locally. And then either your clients, your customers, your colleagues can run the apps and do NGSolve simulations. If you, okay, maybe you explain this? Yes.
Do we have the second microphone?
I can also give you this.
Let's do it like that.
You want to use it?
For him, maybe. I'll use that one. Okay. So there is two kinds of apps. The one type of app is the very simple one, as we showed before, the thrust bearing app, And just to get an idea, I got some code that was just using Python, MATLAB, and doing some matplotlib plots. And I gave it to Raphael, and within a few hours, he actually built the whole app. So with all the options and all the visualization and so on. So this is browser only, and this kind of is the same thing that Jay told us about the Jupyter Lite. So that's this application or this packaging of NGSolve where everything runs in the browser. The nice thing for us is that we only need some static website hosting, and there is no other cloud resources or computing power that we have to provide because the actual calculation is done within the browser. Could be on the phone or on your laptop or on your tablet, whatever. But at one point, you might reach a point where you do some heavy calculations or you need some solvers which are not available. And then with a simple decorator in your Python function, you can shift this to the backend. So then it will allocate cloud resources, the whole computation will run there, and then it sends back automatically all the results, and you see the results on the browser. So that's the other type of app where you are relying on compute resources. So somehow you have to tackle that. So typically, if there are 3 apps available, this kind because the cost is low for us. If you need some calculations and resources, that's the apps that will cost something, like for the journal pairing app, for instance. Yeah.
We also have to pay for this.
Yeah, I mean, it costs something. But that's all automated. So as soon as you start the job, it will look if there's a server available, and if not, it will acquire some new servers from the cloud, and then we'll give them away again. So we only pay for the hours that we actually use. Okay, now lifetime. Let's hope everything works out. There you see, this is the development instance. We have some apps, and I'm going to show you now this meshing app. So you just click on it, and it's loading, and then it's there. There you can upload a geometry. Yeah, then you see some loading time, which is very long, and then you see this geometry, which is very complicated. Yeah, and here, as Christopher mentioned before, you have these shape settings for solids, faces, and edges. And you can click on a face, say this has some name, my face. And then you put some, yeah, let's be on the safe side.
No, I mean,
yeah.
In NetGen,
set some max age, and then we can actually generate the mesh. And this is all done within the browser. So it's just importing NetGen, doing the meshing, and then you see this is very nice. That's what I wanted. So that's basically this meshing app. And now the question is, how do I actually develop an app? So if I want to work on something, I code something, how do I get this into the browser? And basically, I did this before, but here you have, if you are an app developer, you have this dev button. Oh, yeah, it's wrong. It's already running in the background. I'm not running it now. But if you do that, it will copy a command. And you just run this. So it's already running in the background. That's why I'm not starting it now. And this means it's looking at the code you have locally. And every time you change something in the code, it will automatically zip it, push it to the to the backend. The backend pushes it to your browser again, and you will get the updated version. So I show this now. So here we have now this code. The app is not open. Here it is open. Here we have, for instance, this is called shape settings. I just want to call it settings. So I just remove this. I save. And 2 seconds later, it's already updated. And it even keeps the state most of the time. Yeah. That's still a work in progress, but it's working very well. Yeah, and now if we looked at this mesh before, Joachim will already think, this is not curved. We want to curve this mesh, it looks better. So I want to just demonstrate. I have this here. So with a few lines of code, so this is these. Let's do that. So I just write the function, curve the mesh. So I call self.mesh.curve, and then this web GUI draw. So it's using also this web GUI technology. I just draw it, and then I create the button. This is done with this Q button curve. That's the name, and then I just say on click. You also have, if it's working on, yeah. You also have autocomplete, so you see which options are available. Yeah, let's read that again. And now we add the button somewhere. So you have a tree of components and you have to insert them in the right space so that it will actually pop out somewhere. So let's put this here. So curve button. And now if I save, this button pops up here. It's not very nice looking, but just for demonstration. So now we generate the mesh. And now I click this button and the mesh is curved and everything is nice. So that's so far for the demonstration. And if you're interested in that, go to our workshop tomorrow and we will go into more detail and you will develop an app on your own. So that's the plan. Yeah, and I think
one more thing, please let us know if you want so that we can allocate a user for you on this dev instance. So if you're interested tomorrow to try that out, let us know and we'll set everything up.
That's that. Thank you for your attention.
By the way, this was also new to you. This is like the stuff that we do behind the scenes.
So your question at the beginning, does it have to be so complicated or can it be easy? So you know me, I'm very problems often with making decisions. So, but you don't have to decide. You can have the complicated version with HDiff and HCurl, as we have now, and you can have the simple version where you don't worry about this spaces.
Apart from the workshop tomorrow, do you have some documentation, at least links or something?
We started to I mean, this is like super fresh stuff.
Yeah, I know.
We started to write the documentation while doing it, and it's partially there. And the nice thing is actually that you use Corsair components and basically wrap them into Python. So all the stuff basically that you have available is already very well documented on the web. And the only thing we have, like, so you go on this Corsair side and then you see a lot of documentations, examples, how you do this button, slider, whatever. And then you go into our doco and look up how it is wrapped to Python.
so all this is automatically generated, that's why it's there.
But that was also the basically
AI is doing a great job with this.
Yeah.
it's also like
But
it should
first
be.
step, so if I want to create my own app, so what do I have to do and so
That
on?
will be tomorrow in the workshop.
Yeah.
And
There is an app called App Creator.
yeah.
Ooh.
And you put in some stuff and then you click create and then you get a zip file with the whole Python module in place. So you don't have to
Okay.
create it
and
from
actually
scratch.
This is also, if you're an app developer, you have this side here, and then you here have how to
There,
create an
yeah.
app.
We will go through this tomorrow together.
So the actual plan is to keep also this app thing open source and let the community create an abundance of apps, or what is the actual
No.
plan?
Honestly, not fully developed yet, so that's why we also present it to you and get a bit of feedback. Right now our plan is to have like one stable platform where we put the well-developed and maintained apps that we build with friends, partners, whatever. And then we have this app dev instance where you can play around, you can create apps, you can also share them with specific other users. But we also don't want to cluster it with like broken apps that, so maybe in the future we develop some idea how to maintain also like a way for everyone to develop apps on a public one. But for now we don't have the resources to do that. So we do this like, if you have a really cool app, then you can contact us and we can discuss how to put it on the website.
Yes, but how? So can anyone make a really cool app and discuss with you how to publish it, or?
If you're interested in app development, you can get an access to this app dev.
And then play around, yeah. And since you're all part of the NGSolve community, chances are very high that you will get some access. Yeah.
What?
Dinner.
I think so, you have, people are thinking about it and coming tomorrow to the app creator app demo.
Yeah.
Yeah, very exciting to see what what you're doing. Besides fixing web GUI features. So if you want to have some new feature in web GUI, convince them that's useful for the simple platforms, and so it goes the same direction. Visual benefits.
Yeah, last question. So, it once in paradise, so at least the Python source code is like in the cache of the user.
Yes. I mean, we encrypt it somehow, but it's not error prone or really safe to hackers because it's running in the browser. So, of course, theoretically, someone can extract the Python code.
If I use this in business, like I have
yes.
to know that
But you have to.
the user has like
The idea is you have to split the code. So we had this here.
the backend.
Yeah. Any module that's called backend or has backend in its name is not zipped and shipped to the front end. So this is a way to split it, and usually defining the interface, like the buttons and the logic behind the buttons and what it does, is not so secret.
Okay,
And
can
the
I
actual
run backend on my own server, or do
Yes.
I have to use your
When-
steps and server?
when you develop, by default, it's running on your machine basically.
Okay.
So you can do this decorator, and it will actually run everything on your machine and have all the software available that you have locally.
If you want to deploy it somewhere, this is currently only in development, but
No,
we can discuss how. It's in theory, it's super possible.
yeah, we already support. So the goal is to have two different compute environments for the backend. One is using just virtual environment where it's installed some big packages. You give the list, and the other one is providing a Docker file, and then it's building this Docker image on the backend and running everything in there. And I think with that you can already do quite some stuff.
I think we're time-wise.
Yeah.
Let's.
So.
I mean, we can move the discussions
Yeah.
to the dinner. Right?
Yeah.
Okay, I think I want to add something. So questions I got over the last 20 years, I always got questions. Can you do this? Can you do it also in 3D? Yes. Can you do it also non-linear sometimes? Yes. Can you do also this? Can you do also that? And the last open question, can you make it also simple?
That's left to us. Yeah.
Okay.
Should we discuss
Then-
for the sessions tomorrow, like what?
Okay, so I have passed through an
okay.
sheet of paper where many of you signed in. So if you take a good balance of 8 sessions, so all of them will happen tomorrow. Don't worry if you have not signed up, it was just an opinion forming. I think there will be more some sign-ups in app development, which was not presented before. Tomorrow between 9 and 12 we are running these mini tutorials. We have the forums there and we have tables here. And
How do you do it? 1.5 hours or
1 hour I would say, and then switch, yeah.
So-
then another hour, and then
So you will have the chance to attend
Three,
2 or 3
yeah.
workshops in
It
total.
depends a bit on who is managing the tutorial, if you have it ongoing running or...
Have to restart every time.
Yeah. Okay, then I think we close the scientific part of the day and looking forward to the dinner. Thank you.